Hello, let's try to solve a Leetcode problem today. Today we are going to solve number 32, longest valid parentheses. So this is really a hard problem, but it's a very good problem. So we are giving a string containing just the characters open and close characters. Parentheses return the length of the longest valid well formed. For example, so the longest from here is 2, and here the longest is from here is 4. Yeah, here because nothing inside, so we'll return a 0. So inside the s dot last maximum is 10 to the power of 4. So for this kind of problem, normally we'll use a stack. Yeah, because for the stack, it has the open and close parentheses. We can use a stack to do some calculations to deal with this open and close parentheses. Yeah. Now let me go to the whiteboard first to explain the problem. Yeah, basically inside the parentheses can be some open, or close and close. Let me check. It's not loading. Yeah, it can be something like this. We have 3 open and 3 close parentheses, so the longest is 6. Yeah, and we also have some cases it is always be close, not open. So the result will be 0. But what if here is open and here is close? So the result will be 2. So how we are going to solve this problem? It means this kind of open parentheses and closed parentheses, they must be a pair. For example, this is a pair. So we can use a stack to check if this is a pair or not. If it is a pair, we pop this out. Here we don't put it in. Here we can check another one. If this is a pair, we pop this out. Yeah, if it's a pair, we pop this out. But how we are going to calculate the length? So for example, for this one, if we only have open and close parentheses, yeah, we put it inside a stack, we will use index to put it 0 and 1. And how we are going to check it? So if it is an open parentheses, yeah, normally we put it inside the stack. We put a 0 inside. And when we come across a close parentheses, we are not sure this stack on top of the stack it is open or closed. But if it is open, how we are going to do? If it is open, so we just need to use this index 1 minus. Yeah, because if it is open, if it is a closed parenthesis, but before if it is open on top of the stack, if it is open, we don't need to put this index 1 inside. Yeah, we just need to use this index minus what? So 0 is not possible because 1 minus 0 it is 1. It's not the answer. So we need to prepare something in the side of the stack. We need to prepare a minus 1, initialize a minus 1 inside of the stack. In this case, if we come across this kind of a situation, we just need to use 1 minus 1 and we get the result 2. Yeah, so there are some other cases. For example, if it is like this and 3 close, yeah, like here. So if it is open, we put the index inside. So before, as I said, we will prepare a minus 1. So we prepare a 0, 1, and 2 index inside the stack. Yeah, so if we come across a close parenthesis, so we don't know yet if this is open or closed, but if it is only open parenthesis, yeah, we just need to check. So this index is 3, we need to pop this 2, we can use 3 minus 1, so the result is 2 at the moment, yeah. So what about the next? We put a 4, so this index is 4, yeah, when we come across 4, and here we don't know yet. But if we imagine this is only a open parentheses. If it is a pair, we pop this out and use 4 minus here. This is 0. Yeah. And we go to the next one. Next one is 5. And here, if we imagine this is just open, it's a pair, we pop out the 0 and use 5 minus 1. Yeah, minus 1. So the result would be 6. So this is the easy case for such things. Why we need to initialize a minus 1 and why we need to use this stack. Yeah, stack, if it is open, we just append it inside. But if we come across a close, yeah, we just need to pop it out and use the if the index is I minus stack minus 1. Yeah, so the stack inside should be minus 1. Yeah, this is the easy case. But what if we have some close parentheses? Yeah, like this. So the close parentheses, if we have many close parentheses, it doesn't matter. We only consider this last close parentheses. For example, yeah, we only consider this last parentheses. For example, the last parenthesis is here. We have 1, 2, 3 close parentheses. We don't have the open, but that doesn't matter because this 2 and this 3 can never become a pair because when we have open and close, it is always after that. Yeah, since it's after that, we only need to get the index value of the last one. Yeah. So for here, this is 0, 1, 2. We only need to get the index value of 2. We don't even need the minus 1 because we only need this 2. So if we have an open and close, what are we going to do? If we have an open, we put the 3 inside. Yeah, this is index 3. But what is the next one? For the next one, here this is 4. Imagine this is just open. So this will be popped out and 4 will be minus 2. So this 4 minus 2, the result would be 2. Yeah, but how are we going to do that? So if there are several close parentheses, we only just keep 1 inside the index. So we will use a stack to do some things. Normally for the first step, if it is an open parenthesis, we put the index inside. Yeah, we put the index inside. But if we come across a close parenthesis, we need to first pop out. Yeah. If we come across, we need to first pop out. Before it inside, there's a minus 1 inside the stack. If we pop out this minus 1, the stack is nothing inside. Yeah. So the stack becomes empty. After pop out, yeah, we need to put the index inside. For example, here we go to the first one, it is 0, so the stack is 0. When we come across this one, we first pop out this 0 inside because it is not important anymore, and here is important. We put the index 1 inside. Yeah, when we come across this one, we pop out the 1 and put the 2 inside. Why? Because anything before that is not important. Why is this important? Because we will use it as an index for calculations. Yeah, and then when we come across this one, we put the index here, we put the index 3 inside. Yeah, and then when we come across a close, so we need to first pop out this one and we check the stack. If something already inside this stack, yeah, because the stack is not empty, so we can use the calculations to calculate. Use 4 minus 2, we get the result. But as I said before, if the stack is empty, we pop it out. If it is empty, we need always put the index inside. Yeah. Now let me put it in the code editor and then go back to explain it once more with the code. Yeah. Yeah, because this is a really hard problem, because when it comes across stacks, yeah, it is always hard. You need to think a lot about all the situations. So for me, I will define a stack and my result, because the minimum can be 0, because I will use max to calculate the length of the stack. So the stack will be an empty array, and I want to put a -1 inside for easy calculation. Yeah, and yeah, this -1 is also used for the first open and close processes. Yeah, and the result will be 0. And for I in raise len s, yeah, we loop through one by one. We need to check if this I equals to open processes. Yeah, if it is open, we can always put it inside, because open is always useful. We may come across a close after that. Yeah, so the stack will append this open processes, but we need to append the index, because we will use index for our calculation. Yeah, and else, this means this as else, it means this string will come across close processes here, for example. Yeah, and we need to pop the processes, pop the index first, because we imagine this is always open first. Yeah, we pop it out. But what if the stack is empty? Yeah, this is something like we come across always with close. Yeah, if we come across with always close first, not open, yeah, the stack is maybe empty. Yeah, for example, before it is a -1, we need to pop out the -1. We need to update this one. If it is empty, we put a 0 inside, then 1 inside, then 2 inside. Yeah. If the stack is empty, we need to put the stack dot append this I. Yeah, and our result will be always the max of result and I minus result -1, and our final result is the result. Yeah, so like this way, the time complexity can be O(n), because we only use a stack to pop out and put only a one for loop, and inside we just use the stack operation, because step is just O(1) for pop and append. This is why the stack can be very difficult, because it is very fast. Yeah, but for even for this pop out and appending, it can be very difficult. Now let me go back to explain it once more. I hope we can understand why. So this is for the situation for the close. If we have 3 continuous of close processes, so for the previous one and the previous 2, it doesn't matter. We only need the last one. Yeah, because the next one will be open. Yeah, we only need to check the last one. Yeah, so here we just need to record this index 2. We put a 2 inside. So for the next one, imagine this is not close anymore. This is just open. We put the index inside 3. Yeah, and then we come across a close. We need to pop this out and use this index 4 -2 to get the calculations. Yeah, but what if it is always open? Yeah, there's no close. It is always open. So it's also similar for the situations there's nothing inside, just with open. Because here we will use this index to put it in our stack. It is not -1 anymore, because it has been popped out. Yeah, this means if we don't have the close processes, if it is start from open, we always need a -1 for easy calculation, because it can be like that. But if it is always with close first, we don't need it because we popped it out and updated with the latest value. It is a 2 inside. Yeah, and if we, for example, this here 2 inside, after that it will be like 3, 4, 5, etc. and many inside. When we come across close, we can update our values because we only need this 2. If inside it is always open and close, it can become a valid. So we only need to use the last index minus this 2 get the result. Yeah. Now let me run it to check if it works. Let me check. Yeah, int object is not subscribable without X. Int object is yeah, because here is stack minus 1 because we need to use the stack. It's not the result int because here is the int object. Yeah, it's not a subscriber, of course. Now let me run it to check if it really works. Yeah, you see it works. Now let me submit it to prove the explanation is right. Yeah. Yes, you can see it is right. It's like 80% of all submissions. Thank you for watching. If you think this is helpful, please like and subscribe. I will